Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at Omicron, and I will be your host. Hello, everyone. That's the sound of a big boat, maybe a cruise ship, a container ship, or a tanker getting ready to leave the harbor. On board are a series of generators and motors that produce the electrical power and propulsion to move the ship, but before any boat leaves a port, all its rotating electrical machines must be in top condition to ensure reliable operation on the high seas. In the lower levels of a ship, we find not only these critical generators and motors, but also Christian Quell and his team. Christian is the head of testing at ENA, which stands for Elektrotechnik and Aggregatebau. The company is based in Bremerhaven, Germany, and specializes in rotating electrical machine testing, diagnostics, repair, and refurbishment for all types of ships. In this episode, Christian tells us more about his company and his experience testing rotating electrical machines on ships. He explains how testing generators and motors on ships differs from testing them on land, for example, in an industrial plant. Christian highlights the differences in testing environments and time constraints and how they make testing on ships more challenging. Christian also describes the mechanical and electrical installation tests he and his team perform to assess the condition of machines on ships, when these tests are performed, and how test results are documented. He also explains how he and his team ensure machine repairs are performed efficiently and reliably on a tight schedule. So without further delay, welcome, Christian, to this episode of Energy Talks.
Hello, Scott. Thanks a lot for the invitation.
Christian, please describe your company, ENA, and the types of testing services you specialize in.
We are a repair shop for electrical machines and electrical engineering, founded in 1919. We are located in Bremerhaven in the north of Germany. Our main work area is overhaul, repair, and rewind of electrical machines and electrical engineering, especially in the offshore industry, shipyards and ship management. We have a wide range of customers from all industry, but shipyards and ship management with their ships make up about 70% of our projects. From the electromechanical side, we support our customers in their maintenance strategies, for example, condition assessment of electrical machines, overhaul and repair work. The condition assessment is based on two pillars, mechanical and electrical. On the mechanical side, we use vibration analysis and laser alignment tests, and on the electrical side, we use the usual insulation test. Also, offline PD tests are become more and more popular in the offshore industry. Maintenance work includes bearing replacement and cleaning of windings on site. Overhaul in the workshop, such as removing machinery from the vessel, overhaul in the workshop and return to the site, and recommissioning. Our electrical engineering department is often commissioned to reinstall and upgrade electrical systems such as ballast water treatment systems, scrubber systems, or pitch control systems.
How many colleagues do you have working with you at your company?
We have approximately 90 colleagues.
So when you do measurements on a particular ship, how many team members go together to do these measurements?
For the measurements, oftenly one or two persons. So oftenly me and one other colleague. But the main team is mechanical team, which make the hard work at the machines. So the bearing exchange, the cleaning of the winding, or the dismantling of the machines on site.
Okay. And the types of ships that you're working on?
Yeah, cargo ships, cruise ships, natural gas tankers, all kinds of ships.
Okay, so really big ships.
Yeah, from big size to small size.
Very good. What is your professional background in performing electrical testing on rotating machines?
Yeah, after my studies, I started as a test field engineer. As a result, we have built up the area of electrical diagnostics on electrical machines more and more, as the demand for on-site diagnostic measurements is constantly increasing. We have now reached a point where the diagnosis of electrical machines is to become a separate department.
Interesting. So which types of rotating electrical machines do you service in ships?
Yeah, we primarily service machines that are part of the leading machinery, such as shaft generators, auxiliary generators, propulsion motors or electrical propulsion motors, and bow and stern thruster motors.
Okay, so these are motors that are used to generate power and move the ship. Is that correct?
Yes, that is correct.
Are there any differences between servicing these machines on ships and land?
Electrical machines on ships are the same as those in industrial plants on land. The difference in the service work is the conditions around it. The installation situation of the machines on ships is often very cramped and presents more challenges than on land. In addition, working hours usually have to be adapted to the ship's schedule, which requires a high degree of flexibility. If a certain time slot is open, the work must be completed within the time, whatever the cost.
How often and why do machines need to be tested on ships?
Yeah, the technical conditions for electrical machines on ship are not always the best. They are exposed to temperature fluctuations, salty air, strong vibration, and also shocks. The ship is either restricted or out of service if an important electrical machine fails, such as a generator or bow thruster motor. This must not happen on the high seas. A ship must therefore be taken to the shipyard every few years for various maintenance and repair work. During this time in the shipyard, maintenance is also carried out on critical electrical machines such as generators, propulsion motors, if present, or bow thruster motors. During maintenance, standard checks are carried out first. Maintenance work is also carried out during the shipyard period. Time can sometimes be tight. It is common for us to be the last to leave the ship. Condition monitoring is generally carried out infrequently as the effort involved on ships is considerably higher than the industrial plants.
Interesting. So what types of tests are you performing?
The scope of the machine's test must be adapted to assess condition. The machine's technical design data play a role. The most used tests are vibration measurement with condition assessment of the bearings and insulation measurement of all windings and auxiliary components, resistance measurement of all windings and auxiliary components, and measurement of the polarization index. For low voltage machine, I then measure DC high voltage and surge test. This become particularly interesting for machines in the voltage range of 6 or 10 kilovolts when I can carry out partial discharge measurement and loss factor measurement. I have really experienced some real surprises here.
Hey, Christian, what kind of surprises are you referring to?
Often it is a condition of the measurement result that are very surprising. Here a small example. There was a container ship, had water ingress in the bow thruster room, which meant that the two 6.6 kilovolt bow thruster motors were standing in 5-meter deep salt water for around 3 days. After the room was drained and our colleagues had completely dismantled the motors on site, cleaned them, and replaced the bearing within a week while the boat was underway, a PD measurement was to be carried out to the end. I was worried that I would see high surface discharges due to residual salt deposits. Surprisingly, the measurements show very, very low partial discharges. That was very surprising for me, absolutely not expected.
Interesting. So what is the most critical test in your opinion?
In my opinion, no test that provides information about the condition of an electrical machine or its insulation system is critical. Of course, there are tests such as partial discharge measurement that can cause damage to the machine or its insulation system. However, its damage only occurs when the insulation system is severely damaged. In such a case, the operator should be happy that this damage was detected during a measurement. Otherwise, the machine would very likely fail unexpectedly during operation. The resulting cost would certainly be many times higher.
That's interesting. It is often said, however, that partial discharge measurements are non-destructive measurements. You seem to contradict this characteristic. Can you explain this again in a little bit more detail?
Well, as long as the insulation system is not permanently damaged, a PD measurement is also non-destructive. However, if the previous insulation measurement shows that the insulation system has a very low insulation value, this indicates damage to the insulation system. In such a case, a breakdown can also occur during the PD measurement. Fortunately, I have not yet experienced such cases.
Christian, thank you for that explanation. What testing equipment are you using for your tests?
Oh, there are many. I use a different measuring device for almost every measurement. I prefer a measuring device with an analog display for standard insulation measurements. Based on the needle deflection, you can immediately see whether it's good or bad. Reading errors are very unlikely compared to a digital display. I also use a Baker Advanced Winding Analyzer for DCI voltage test, which has been with us for many years. I use also Omicron's CBC 80 and TD's 12 with MPD 600 device for partial discharge measurement and loss factor measurements. For vibration analysis and vibration measurements, I use Microlog from SKF.
Do you have a favorite testing device for overall diagnosis?
No, I don't have a favorite device. I'm also not a fan for comprehensive testers for electrical machines. All the devices I use have their own individual strengths, and not every device is needed for every measurement. So it's good if you can put together the devices based on what you need.
Fair enough. Okay. So, Christian, could you please describe the testing environment on ships? Are there any specific challenges?
Yeah, every ship has a different test environment. The most common factors that make working on a ship very difficult are very little space, dirty environment, sometimes very high temperatures, or a very noisy environment. Language challenges should not be underestimated due to the large number of nationalities on a ship. Transporting machines or machine parts can also be a big challenge if other components have to be dismantled or removed to make enough space. This can cost a lot of time.
Christian, if a problem is found, do you remove and repair the machine in your workshop, or do you perform the repairs on the ship?
Yeah, it always depends on the extent of the damage. If the machine has a defective winding, there's no other option than to remove it from the ship and repair it in the workshop or rewind it in the workshop. This sometimes requires cutting open the hull of the side and then transporting the machine through the hole in the hull.
So they would actually cut a hole in the ship to get to the machine?
Yes, that's right. However, if the damage only affects certain components, often only these are removed from the ship and then repaired. We try to avoid repairs on site because professional maintenance is essential to us. Depending on the size and the type of machine, it may also happen that a machine is completely dismantled on the ship and taken out of the ship by individual parts. So step by step.
Okay. Christian, what type of turnaround is expected?
Yeah, availability and efficiency are significant issues. Every unplanned failure ties up unplanned resources and costs money. Often it is not the pure repair costs of machine, but rather the additional costs that make up most of the losses. It is increasingly recognized that damage to a machine can be detected long before it fails. This applies to mechanical faults such as bearings and electrical faults such as the insulation system. There's a clear trend that the people responsible for technical matters are placing increasing importance on assessing the technical condition to better plan repair measures and thus save costs.
Interesting. If you have to remove a machine for repair, do you offer replacement machines while the original is in for repair?
Yes, some shipping companies share a pool of replacement machines if they have identical ships. The replacement machines are usually used machines that have already been overhauled. This means that a quick response can be made in the event of damage, and the entire change can be completed within a few hours. Our colleagues then drive to the ship with the replacement machine exchange the machines and bring the defective machines in our workshop, even if the machines sometimes weigh 2 or 3 tons.
How do you know if a repair has been successful?
If a machine has been repaired in our workshop, a functional test is carried out on the test field before it's reinstalled. All electrical and mechanical parts, as well as the heating of the machine, are checked. Delivery only takes place when the machine has passed all tests. After the machine is reinstalled, another test run is carried out on site to ensure no problems arise. This level of care is necessary because a possible warranty claim on the high seas is extremely costly, not to mention the damage to the company's reputation.
Does the customer require you to document the test results, Christian? And if so, how do you prepare this and what does this documentation look like?
Yes, of course. The relevant test reports are very important. We document all measurement results in the test reports. Not only does the customer require this document, but the classification society such as GL or Bureau Veritas also requires test reports as proof of professional repair. Depending on the extent of the repair, an inspector from the classification society may come to our workshop for visiting the test run. I always try to create the documentation so that even someone who is not an expert can understand what is in it and that an expert later has the information to recognize any change in the condition.
So what are some of the ways you make your documentation easy to understand?
To ensure that the documentation is understandable for everyone, a clear structure and the separation of different subject areas is very important. In addition, the documentation, for example, its structure and content, is often explained in a personal conversation.
Okay, so do you have any tips on how to make testing machines on ships most efficient?
Communication and proper preparation are the keys to conducting tests efficiently on a ship. There will always be factors on board that make life difficult. The more you roll out in advance, the more efficiently the test can be conducted on the vessel. I have learned a significant aspect from my work on ships. Things always turn out differently than you expected.
So in addition to proper preparation and communication, how do you deal best with the unexpected?
It's always important to stay calm. Wait a little and make the best of the situation. Often it's just organizational challenges that resolve themselves through communication and waiting.
Okay, so Christian, what is your favorite aspect of your work and why?
The technology on board a large ship is awe-inspiring. It is also an excellent feeling when you can use your specialist knowledge to help solve problems, and the ship can leave the harbor again because you have done a great job.
Christian, thank you very much for joining me on this episode of Energy Talks to share your knowledge and experiences with the condition testing of motors and generators on ships.
Thank you, Scott. It was a pleasure to be part of your Energy Talks podcast.
And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.